name is Andrew Fursman. I'm the CEO of qubit. With a quantum computer, you really, for the first time, get to take advantage of the fact that we live in a quantum mechanical world, and we're going to try and harness those quantum mechanical effects and use them to do computation. So quantum computing, in some ways, is actually very similar to classical computing, in that if you talk to most people about how their classical computer works and say like, just draw me the schematics of the 30 billion transistors in your cell phone, the answer is probably like, I can't do that. And with quantum computing, it's very similar in that it's a very technical construction. But at its heart, what quantum computing is really trying to do is to use a deeper level of reality and a thing that's happening at a small scale that has not been tapped into with classical computing as a resource. So in a classical system, the fundamental unit is the bit. And in a quantum system, it's a quantum bit, and we just call it a qubit. The idea is that a lot of these types of fundamental components have been so challenging to build, but actually that's not the hardest part. The hardest part is building one and then building two and then hooking them together and then trying to take those two and making it into four. So it's not as though, wow, it was really hard to build a qubit, now let's build a billion of them. It turns out that linking qubits together is incredibly challenging. So we're kind of in a place where we're playing around with all these different methods of what a qubit could be. And the nice thing is, every big company and all the little startups that are trying to get in on this, they all have a slightly different method of doing this. So some people are working with ion traps, some people are working with superconducting qubits, but even within each of those, everyone's exploring their own different way. So it's like we're all searching to find what's the ideal way to build this fundamental unit of computing for this new paradigm. And then, what are the scaling properties looking like? And we're just getting to the point where this is even approaching possible. And there's been a tremendous amount of work, a tremendous amount of financial resources, human intellectual capital, people really dedicating the vast majority of their careers and their lives towards trying to realize these devices. And this is the moment when it's all really paid off, and we're just getting to that tipping point. Everything's up for grabs and anything could happen. It's really an exciting time for the industry.